Hello, in this video we're going to learn how to find the derivative of an exponential function with a constant base. Any one. For example, this one. But we're going to solve this later. So let's learn how to first. Alright. Now let's be given any form of this question, exponential function with a constant base. Let's say we have a function with a constant base a. Now, exponential function, that means with raised to x, where x is the exponent. So let's say it is the power is a function of x. Okay, even x on its own is a function of itself. All right. So if you are asked to find the derivative of this man here, that's just it. How can we find this? So I'm going to give us a general formula to solving this kind of thing. Anyway, you see a constant base 3 to a function of x and x, then you should learn how to differentiate this. Okay. So to finding the derivative of this, we are going to assign a variable for it. Let's say that y is equals to a raised to the power of f of x. All right, so we go further by saying take the ln of both sides. So I'm going to say ln of y equal to the ln of this. So we take the ln of both sides. So we say ln y should be equal to the ln of a to the power of f of x. All right, so at this point, this is just f of x. So at this point, we're going to differentiate both sides. Now take note that we take the ln of a number with the power is going to come back and become ln of y, which is equal to the ln, sorry, so the power is going to come back and become f of x times the ln of a. So we go further to differentiating this, we will have the derivative of y just 1 over y. Take note of the implicit differentiation, dy dx equal to, now, we are going to differentiate this with respect to x. So that will give us f prime of x. So if you differentiate any function of x, that's just f prime of x. Now, take note that this is a product, so we're going to apply product rule here. So if we differentiated this one, we're going to keep this one constant. That will become ln a plus, now take note that we say the constant base, so a is a constant, plus, now we're going to keep this one at this point, f of x times, now we are going to differentiate ln a. Take note that the derivative of the constant is just 0. So ln of the constant is a constant, therefore it should be 0. So f of x times 0 is just 0. So we don't need that part. Okay, so we go further to make the y the x object of formula. So the y, the x, will now become, cross multiply both sides by y. That will become y times f prime of x ln of a. Okay, so at this point, we take note that our y was equal to what? A raised to the power of fx. So this should become the y dx is now equal to, put the value of y, that is a to power fx of x times the whole of that bracket times f prime of x, okay, ln a. Is the differential coefficient or the derivative of this kind of example. So you just plug in a raised to the power of x, everything times the derivative of the exponent times the ln of the constant base. Okay, so let's use this identity here. This is just a to the power of f of x times f prime of x ln a. So we're going to make use of that identity to solving this problem. So we just go and apply this for this left hand side. Now, I want you to note that we want to differentiate this, that this one has a logarithm here. So let's assign a variable for it. Let's just say y equal to 3 to the power mx log of x to base m. Okay, so I'm going to split this. I'm going to rewrite this in this way. I'll say y equals to 3 to the power mx times. Now, I'm going to apply change of base here. You know, log of x to base m can be equal to ln, you know, I'm going to change the base to base e. So that will become ln x over ln m. So this is just 3 raised to the power of mx times ln of x over ln of m. Okay, so from here, I'm going to apply product rule to differentiating both of these. So I'm going to say the product rule to differentiate this will just the y dx will now become the derivative of this man here, okay, so that will become 3, this other one, 3mx times differentiating this is just the derivative of ln x is just 1 over x times ln m. So the derivative of ln m is just 0. So we keep it right there. Plus, so we're going to differentiate this and keep this. To say ln x over ln m times, so the derivative of this here, let's apply this. That would become everything there, 3 to power mx times f prime of x. So where f of x was just the power, so f prime of x is just m times ln of a is what? Ln of a is the ln of the base, which is ln 3. Okay, so this divide the x will now become 3 to power mx, factorize that, times inverse of this, that's just 1 over x ln m, plus this is just we can still rewrite this back to where it came from. It came from log of x to base m, so this would become plus log x to base m times, I factorize this here, so times m times ln 3. All right, let me go ahead and clean this right here. So we are going to split these out, and you see it clearly that we're going to have 3 raised to the power mx. Now, inverse of x, 1 over x, inverse of x ln m is just 1 over x times the inverse of ln m. Okay, plus, now we have m log x to base m times ln 3. Right, so at this point, this ln 3. At this point, I'm going to say that the inverse of a logarithm, okay, if you have log of a to base b, take the inverse, it's just going to be log of b to base a. So I'm just trying to simplify. Already we've gotten the solution already. That become inverse of a times log of e to base m plus m log x to base m ln 3. So this can be okay for us, or even stop it before this step. But I want you to understand how it's been done. Alright, thanks for watching. Please subscribe to this channel.